Module 1, Introduction to Automobile Mechanics. Module Overview. Module 1 serves as the foundation for the entire course in automobile mechanics. It introduces you to the automotive industry, the evolution of automobiles, the basic principles of mechanical engineering applied to vehicles, and the fundamentals of automobile design, structure, and operation. A strong grasp of this module will provide you with the conceptual framework required to understand all subsequent modules that deal with advanced systems, diagnostics, and repair techniques. This module not only addresses technical understanding, but also highlights the importance of mechanics in society, the role of automobiles in global development, and the connection between technology, safety, environment, and innovation. 2. Historical development of automobiles. Early inventions. The automobile evolved from steam-powered carriages of the 18th century, Nicolas-Joseph Cugnot's steam vehicle in 1769, to Karl Benz's internal combustion engine-powered automobile in 1886. Mass production. Henry Ford's assembly line in the early 20th century revolutionized automobile accessibility, making cars affordable to the middle class. Modern advances, from carburetors to fuel injection, manual gear systems to automatic and CVT transmissions, traditional petrol and diesel to hybrid and electric vehicles. The future, autonomous vehicles, AI integration, hydrogen-powered engines, and environmentally friendly designs. This historical grounding helps you appreciate how mechanics adapted to technological progress. 3. The role of an automobile mechanic. An automobile mechanic is not merely someone who repairs vehicles. Rather, they are technicians who apply engineering concepts to diagnose and fix problems, innovators who adapt to the evolving world of automotive technology, problem solvers who understand both the mechanical and electronic systems of vehicles, contributors to safety by ensuring roadworthy vehicles, environmental guardians by maintaining efficient engines and reducing harmful emissions. 4. Basic principles of automobile. 3. Leadership models for strategy in social enterprises. Social enterprise leaders often employ hybrid leadership models. Transformational leadership inspires people around a shared vision. Servant leadership prioritizes the well-being of communities and employees. Adaptive leadership adjusts strategies to fit dynamic and complex environments. Participatory leadership involves stakeholders in co-creating solutions. These models allow leaders to combine innovation with inclusivity and rigidity with flexibility, ensuring strategy execution remains people-centered. 4. Basic principles of automobile mechanics. Automobile mechanics is founded on applied principles of physics, thermodynamics, hydraulics, and material science. You must understand, energy conversion, chemical energy in fuel is converted into mechanical energy via combustion. Motion and power transmission. Engines generate power which is transmitted through the clutch, gearbox, driveshaft, and wheels. Friction and lubrication. Movement requires controlled friction. Lubrication reduces wear and enhances efficiency. Cooling systems. Heat from combustion must be dissipated to prevent engine damage. Suspension and stability. Vehicles must absorb shocks while maintaining control and safety. 5. Components of an automobile. You will be introduced to the main systems of an automobile: engine system, petrol, diesel, hybrid, electric; transmission system, manual, automatic, CVT; braking system, drum, disc, ABS, regenerative braking; suspension and steering systems; electrical and electronic systems; ignition, charging sensors, ECU; fuel system, carburetor, fuel injection, pumps, filters; body and chassis, frame, panels, safety structures; HVAC system, heating, ventilation, air conditioning. This bird's-eye view allows you to grasp how each part works together to make the vehicle functional. 6. Safety, tools, and workshop practices. Mechanics must prioritize safety both for themselves and for the vehicle owners. Students are introduced to personal protective equipment, PPE, gloves, goggles, overalls, ear protection, and safety shoes. Workshop safety, proper ventilation, handling of fuels, safe use of lifting jacks, fire safety protocols. Basic tools, wrenches, spanners, screwdrivers, torque wrenches, hydraulic lifts, multimeters. Specialized diagnostic equipment. OBD scanners, oscilloscopes, computerized diagnostic tools. 7. Environmental and ethical considerations. The module also emphasizes the broader responsibility of mechanics. Environmental responsibility, proper disposal of engine oil, coolant, and batteries. Sustainability, awareness, supporting fuel-efficient technologies, promoting electric vehicles. Ethical service, honest assessment of problems, transparency with clients, avoiding exploitation.